Now the next classification is based on the amount of solute present in definite amount of solvent. See, based on this, we have two types of solution. The first one is a dilute solution. The second one is a concentrated solution. Okay. See, dilute solution is the one in which there is a relatively less amount of solute. Whereas a concentrated solution is the one that consists of relatively more amount of the solute. Two types. Yes. Now, let me give you an example. Supposing if we have, say, one 40% solution and another 60% solution. Sort of supposing if we take these two, then the first one, which has relatively less amount of solute, is said to be a dilute one when compared to the other, whereas the second one is said to be a concentrated one, right? So it's a relative thing. Okay. Even if you consider, say, 10% and 90%, 10% is dilute, 90% is concentrate, right? So that way, depending on the amount of solute that is present, indefinite amount of the solvent, we can say dilute and concentrated solution. Now, the other classification, which is based on the amount of solute present in certain amount of solution. Solute in solution. Now in this we have three varieties. First one is unsaturated. Unsaturated. The second one is saturated. Third one is supersaturated. Now what is unsaturated solution? A solution which has got less amount of the solute dissolved in the solvent than required for its saturation. See, when a solvent is taken, it will have a saturation level. If the solute is dissolved in the solvent in a quantity which is less than what is required for its saturation, we call it unsaturated. Means it can still dissolve some more solute, isn't it? You know, this of course depends even on temperature. Solubility depends on temperature also. We can say that suppose if this is cooled, on cooling, this unsaturated solution may become saturated. I mean, at that temperature, the dissolving capacity will be less. Okay. Similarly, if suppose it is heated, what happens? Unsaturation further increases, right? So on cooling, it becomes, I mean, it may become saturated at that particular temperature, and on heating, of course, if it can dissolve more, we can say that its unsaturation has further increased. So this is the first variety, unsaturated solution. Then going for the second one, saturated. What is a saturated solution? If suppose exactly required amount of the solute is dissolved in the solvent, I mean exactly the amount that is required for its saturation, if at all is dissolved in the solvent, we call it saturated. I mean, it will have a maximum amount of solute what the solvent can dissolve. Maximum amount of solute. Oh, yeah, actually. Maximum amount of solute is dissolved in the solvent that is required for its saturation. Means it cannot dissolve further. But even after this, if we try to dissolve some amount of the solute in that, it has already got maximum amount of the solute dissolved. But still, if we try to dissolve some more solute, then an interesting situation arises. If some more solute is added, when some more solute is added, this solute, I mean the newly added solute dissolves. At the same time, the solute which is already in dissolved state in the solution comes out. So this is very interesting. We feel as if the solute what we have added has not dissolved. No, that is wrong. the solute what we have newly added, it actually dissolves. It makes collisions with the solvent molecules, and of course it gets dissolved. But at the same time, the solute which is already in dissolved state in the solution actually comes out. So there exists a dynamic equilibrium between the dissolved and the undissolved solute particles. Between already dissolved and now dissolved or undissolved solute particles. Undissolved ones try to dissolve, but at the same time, the dissolved ones they just come out. So that is what we say dynamic equilibrium. Now coming to the third variety, supersaturated solution. As the name itself indicates, that here more amount of solute is dissolved in the solvent than that are required for its saturation. Right. But you know, not all the solutions form supersaturated solution. Will not be in a position to dissolve a more amount of solute than what the solvent can actually dissolve. It is not possible in all the cases. There are very few substances like hypoalum. These are the best examples. See, when alum is dissolved in water, you can just go on dissolving. But you know, this supersaturated solution is in fact a metastable solution. What do you mean by metastable? Not fully stable, because it has got more amount of the solute than what is actually required. So this more amount of solute is the reason why it becomes metastable. Let me tell you. Now, to this metastable solution, you know, it can actually become normal or a saturated one. I mean, the extra solute may come out and doing something. Like, for example, see, even on gentle shaking, excess of the solute may come out. Or on scratching walls of the container using a glass rod. I mean, any kind of a disturbance is enough to cause the extra amount of the solute come out. On simply shaking or on scratching the walls of the container using a glass rod, or on adding a small crystal, a very small crystal of the same solute. Now, this is what we call seeding agent. This small crystal of the same solute, when added, it makes the solute that is already in dissolved state to come out gushing. Okay, so this is the reason why we call a supersaturated solution a metastable solution. Just on gentle shaking, excess solute comes out, or even adding a seeding agent or on scratching. Okay. Now let us go for the interesting part of this topic. The first interesting one, that is methods of expressing concentration. First of all, what is concentration? Simple. Concentration is nothing but the amount of solute present in certain amount of solution. Right? Simply, solute in solution. Okay. Now there are different types of methods which we use for expressing the concentration. There are about, say, 12 methods of expressing concentration. Let me tell you. The first one is weight fraction. Next, it's weight percent. Then volume fraction. Volume percent. Now these can be given with respect to solute or with respect to solvent. Generally are given with respect to solute. Even we do the same. Next. Then see, the next one is the strength. Okay. Then there is a solubility. And then we have molarity, represented by capital M. Formality, represented by capital F. Next, normality, represented by capital N. Molality, represented by small m. Then mole fraction, represented by this symbol. We say chi or chi. Then there is parts per million, ppm. So these are the different varieties of expressing concentration, different methods used for expressing concentration of different solutions. Let us take them one by one. So coming to the first one, weight of fraction. As I said, I'll be taking it in terms of solute. See, whenever the word fraction is used, remember it is out of 1. Now, in this case, it is weight of fraction. So let us take it out of 1 gram. Now, what is weight fraction of the solute? See, it is the amount of solute in gram present in 1 gram of solution. Weight of fraction. So simple. Solute in gram present in 1 gram of the solution. Now, let us take the small w as the weight of solute, capital W as the weight of solvent. Now, see, supposing if it is taken as small w plus capital W, gram of a solution has small w gram of a solute, then 1 gram of the solution will have how many gram of the solute? This is what is weight fraction. So this, of course, can be written as small w by small w plus capital W into, of course, 1. So this is the weight fraction of the solute. If you go for the weight fraction of the solvent, it will be capital W by small w plus capital W. Right? So it's that simple. Now this is weight fraction of the solute. We'll go for the weight percent of the solute now. Now when I deal with percent, it is out of 100. Now, because this is weight percent, let us consider it out of 100 gram. Then, see, it is the amount of solute in gram present in 100 gram of solution. Solute in gram present in 100 gram of solution. Told you very clearly that all these methods will be dealing with solute in solution. Now, the same thing. Small w plus capital W, gram solution, if at all has small w gram of a solute, then in this case, 100 gram solution will have how many gram of solute? So this can be written as small w by small w plus capital W into 100. So this is our weight percent of the solute. Now the same thing can be written as, we know that this is actually the weight fraction, what we have seen just now. Now this can of course be written as weight of fraction into 100. So just like fraction into 100 is percent, in this case it is weight fraction into 100, is weight percent. Okay. Now, the third one is volume fraction of the solute. Again, fraction refers to one, volume, of course, can be taken as ml or liter. Let us consider ml. Volume of solute in ml present in 1 ml of solution. Fraction, so I've taken 1. Solute in ml present in 1 ml of the solution. Let us consider the small v as volume of solute, the capital one as the volume of solution. Now, if small v plus capital V, ml solution has small v ml of solute, then 1 ml solution will have how many ml of the solute? So this can be given as small v by small v plus capital V into, of course, 1. So this is our volume fraction. Okay. Small v by small v plus capital V. Next, let us go for volume percent of the solute. 100 ml. So out of 100 ml, let us take it that way. Volume of a solute in ml present in 100 ml of the solution. So very simple. This can be given as small v plus capital V. ml solution has small v ml of a solute. Then 100 ml of the solution will have how much? This is small v by small v plus capital V into 100. This is our volume percent. Now the same volume percent can of course be given as, say, this is volume fraction, right? Now this can be written as volume fraction into 100. Okay. So this is about volume percent. Now some interesting points here. You know, weight fraction, weight percent, volume fraction, and of course the volume percent. You know, these all are ratios, isn't it? All these are ratios, therefore have got no units. Okay. So this is one important point. Now going for few more interesting points. Very, very important. Let us take this X% solution W by W, or let us take it as weight by weight. Let me tell you that this is X gram of solute present in 100 gram of solution. The first, the one that is taken here refers to that of solute, and this one refers to that of solution. Okay. Now, let me write this. X gram of solute present in 100 gram of solution. Don't get confused with solvent here. I told you very clearly that whatever we are dealing with now are those which refer to solute in solution only, not the solute in solvent. Okay. Now, let us consider this. X% solution, say weight by volume. Now look at this. X gram of the solute is present in 100 ml of solution. It's the same. X gram of solute is present in, here it is 100 ml of solution. Okay. Then X% solution volume by volume. See, in this case, it's X ml of the solute is present in 100 ml of the solution. X ml of the solute is present in 100 ml of the solution. Finally, it's X% solution volume by weight. Right. Now, this can be given as X ml of the solute is present in 100 gram of solution. X ml of the solute is present in 100 gram of the solution. Okay. These are the interesting things which we make use of while solving the problem. Generally, it is given as say 10% sodium hydroxide solution, W by W or W by V or V by V. This way, it is given. So, making use of this information, we can solve them easily.